Welcome back. So far in the series, we've explored sequential chains where each step executes one after the other, and conditional chains where the workflow can branch based on certain conditions. Now we're moving into another powerful concept in LangChain called parallel chains. So what exactly is parallel chain? So in simple terms, we can say that parallel chain allows us to run multiple workflows at the same time, independently of each other, and then combine their results. So think of it like a team working on various tasks simultaneously. So one team member is taking notes, another is taking or like creating quiz questions, and then later on, someone merges both into a final report. So by doing things in parallel, we can save time, make the workflow more efficient, and then handle multiple aspects of a task at once. And then that is also key advantage of parallel chain, efficiency and modularity, because each component can focus on a specific task without waiting for the others to finish. And once all the parallel tasks are complete, the output can be combined in a meaningful way, creating a complete and comprehensive result. So what are we going to do in this video? So our plan for this video is, first we'll take a block of text, then we'll run two parallel tasks. One will generate short and simple notes from the text, and then the other will generate a set of short quiz questions based on the same text. And then finally, once these two parallel tasks are done, we'll merge the notes and the quiz into a single comprehensive document. This will show exactly how parallel chains can handle multiple output at once and then combine them seamlessly, making our AI workflow both fast and organized. Now, let's jump onto the code. So create a new file called sequence parallel chain, not sequential chain, parallel chain.py. Okay, first of all, our language model, then a .env function, then I need a prompt template which will get from langchain.prompts. Let's also use the str output parser. And we'll have a runnable parallel from langchain.schema.runnable for our for our parallel chain to run here. Okay, now let's load the credentials, define a model. Now, first of all, I'll define a prompt. First prompt will be about generating a short and like let's say generate short and simple notes for or from the following for the following topic, sorry, for the following topic. We will place a topic in the placeholder. Our input variables is going to be topic. We're not going to enforce any kind of schema for our response right now, so we'll just leave it to this. Our next template will be a prompt template, and this will be about generating generate 5 short question answer from the following text. Our input variable is going to be a text, and then after this I'll have prompt 3, prompt template. This will generate okay, short question answer is done, and then the summary is also done, right? So we will have prompt 3 to merge the provided notes and quiz into a single document document, then I'll provide notes in notes placeholder, and then quiz in quiz placeholder. Okay, so now let's create an object of our parser here. So parser equals to str output parser. I'm going to create a runnable chain or a parallel chain, which will be done using runnable parallel. The first component of this chain is to create nodes, and I'll name it nodes. How we'll run this is we'll first start with prompt 1, then pass it to the model, and then model, and then run a parser on it. In the second chain, we'll name it quiz, and we'll pass prompt 2, prompt 2, then model, and then a parser. Okay. Now we'll call our final chain, which will be prompt 3, and then model, and then parser. Now we'll combine the sequential chain here, final chain, and then the parallel chain, runnable chain here. We'll call it chains equals to, first of all, we'll execute our runnable chain, and then we'll execute our final chain. We'll invoke this chain dot invoke, and then we'll provide an entry point for this one. So the entry point to this chain has to be a text, right? So a topic or a text here. Okay, I'll just try to make it uniform, but it's okay even if we don't make it uniform, uh, because one is going to go in topic and then the other is going to go to text. I think I don't need to make it uniform, I guess. So let's write a text here. I'm going to copy this text from someplace else, but I will be using a word wrap so that you can copy this, or like use any text that you want from anywhere. So this text is about support vector machines. View word wrap. Okay, everything is wrapped inside this view. Now what I'm going to do is I'm going to invoke this. Simply invoke this text. The result is going to be stored here. Result equals to chains.invoke. And then finally, I'm going to print my result. So this is my parallel chain implementation here. Let me run this code and then I'll explain what is happening here. Okay, while the code is running, let's go up. We have prompt 1, which generates a short and simple note about a following topic. Prompt 2 is like generating short answer question, the following topic. And then prompt 3 is about merging the output from prompt 1 and prompt 2. We have a parser, and then I have initialized a runnable chain where we run these two chains in parallel at first, and then the output of these two chains are then merged with the final chain, and then a response is created. So if we see here, so basically a complete node is created where we have support vector machine nodes. The node is created here on top, and then the quiz is created here on the second, and then both of these are combined into one comprehensible documents. So this is how we implement parallel chain in LangChain. So I hope this runs on your end too. If you have any questions or if you have any queries, feel free to comment down below and I'll try to help you out. I will see you in the next video again. So now we see that we get a positive response, and then there are the the model classifies this feedback as positive, and then based on it, it generates a response. Now I'm going to change this. Okay, the phone is actually horrible, the UI is stuck, and then things like that. The UI is stuck, and then if I run this, so the model is in fact giving out a lot of things, but you know that we can structure the output using the pyrentic output parser, or this or like we can base it on some form of schema, as we've already done earlier. So you can actually uh, implement it yourself. So here we get that the response. Okay, so it says that when responding to negative feedback, so it classifies the feedback as negative here for this thing. So in this video, we saw how we could implement conditional chains using runnable branch, runnable lambda, as well as how we could combine a sequential chain and a conditional chain into one, and then make our workflow automated here. So I hope this runs on your end. This is all for this video. If you have any queries, feel free to comment down below, and I'll try to help you out, and I'll see you in the next video.